Hello everyone, and welcome back to Comm 215 Business Statistics. Before we get started, we'd like to thank you for your continued support on our Facebook page. So as promised, we're now about to deliver part 2 of the Comm 215 midterm review, which is the problem solving part. So without further ado, let's get started with the box plot problem. As part of an operations study, a bank operations analyst observed the length of time in minutes to complete a transaction for a random sample of 40 customer transactions last month. And then we have the data, so we have our 40 data points, and then they're asking us for 4 elements. The first one is to construct the stem and leaf diagram. The second one is to compute the 5 numbers required to construct the box plot. So those are the 5-point summary, also called the 5-star points. The third part is to construct the actual box plot and identify any outliers if applicable. And finally, to comment on the shape, or otherwise known as the skewness, of the data set. So let's go ahead and do one thing that is very crucial that I talked about in the theoretical portion, which is order your data. Okay, this is a little bit tedious, but it's really going to come in handy as you solve these problems. So always, whenever you have data set at the top, just get into the habit of ordering it. That way it'll make finding the median, the min, the max, everything so much easier. Okay, so let's go ahead and do that. Now feel free to fast forward to where I'm done ordering the data. All right. Wonderful. So we are all done. Now, one thing I suggest that you do once you're done, like I said, I know this is a bit tedious, but you're going to get much faster at doing this the more problems you practice with. So now what we're going to do is we're just going to cross-check with the data at the top to make sure that we didn't forget anything. So you see, we forgot one. We forgot 7.9, so let's go ahead and add that right here, 7.9, which is right here. And let's keep going. So then we're just missing 2, so 9.5 and 9.7. So it was just a little mistake instead of the 8.0. I apologize for that. So 9.5 and 9.7. Awesome. So we're good to go now that they're all ordered. So when building your stem and leaf display, this is the stem right here. Now on the left-hand side, we're going to have the different branches, if you will. So we know that because our numbers are ordered, see how easy this is, we know that the smallest possible number is a 0 and the biggest will be a 9, right? So for the branches, so we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way until 9. Okay, we know that those will be our branches. And now we're going to fill in for the leaves on the right hand side. Okay, so I'm just going to put this here for you to remember. So these are the branches, which are all the categories, if you will, on the left-hand side. And on the right-hand side, you're going to have all of your leaves, which are going to be filled in with all the data, right? Now, the first number is 0.2, right? So because my branch is a 0, I'm going to put a 2 right there, right? Now, the way the stem and leaf works, and I want you to follow this closely, if I take this number and I simply extract it from the stem and leaf, I'm going to get 0.2, right? Just plain and simple. If I take this number out, it's 0.2. So then, in order to find the leaf unit, what you have to ask yourself is, what do I have to multiply 0.2 by in order to get what's in the data set, which is 0.2, okay? So remember, you extract the number straight out of the stem and leaf, just 0.2, and then what do I have to multiply this number by in order to get the actual data point, which is 0.2? So in this case, it would be times 0.1, and this would give me 0.2. So notice how this is my actual data point. This right here is simply extracted directly from the stem and leaf. And this right here, so the in between, what you're going to multiply by is going to be your leaf unit. Okay, we're going to do a couple of these and you'll see it's going to become second nature. Okay, so now we have our leaf unit. So we're going to put our leaf unit over here to remember, and we're going to do the exercise 1 or 2 more times in order for it to really sink in. So we know that the next number is going to be 0.4. So I'm going to put a 4 here. You don't have to put the commas if you don't want to. You can literally just line them up one after the other. I think it's a bit cleaner, but it's entirely up to you. So once again, let's retry the exercise. If we extract the number from the stem and leaf as is, so we get 0.4, right? But we know that the actual value is 0.4. So you have to ask yourself, by what do I have to multiply this to get my actual data point? And that is your leaf unit, okay? Now, for those of you that are more comfortable, you can obviously do it the other way around, meaning that you can take your actual number and then ask yourself, by what do I have to divide it by in order to just be able to put 0.4 in the stem and leaf, okay? I think this way is easier, but it's really entirely up to you. So then let's just fill it in for the rest of the stem and leaf, and feel free to fast forward to the point where I'm done. So we're all done. So this is what your stem and leaf will look like. You literally simply put in for all the branches, you add in all the different data points, and then this is pretty much how you build your stem and leaf. So this is question A. Now, one thing I want to point out, because they do ask you to comment on the shape of the data set in part D, there's 2 ways that you can comment on the shape of the data set. We're going to do it a little bit later once we do the box plot, but you can also do it right now as you do the stem and leaf. So I'll show you what I mean by that. Notice how the data goes like this, right? So this quite simply means that if we were to flip it vertically, what we would get, so let's just put a line right here, just to give you an idea. You can see that the data set is right skewed or positively skewed, okay? Notice how the arrow is going towards the right. So once again, just pretend that it's flipped over as if you were to see the bell-shaped curve on its bottom. And you can clearly see that it is right skewed, right? Now remember the other trick that I told you to be able to tell whether it's right or left skewed? And that is where the median and the mean fall, right? So we're going to compute that in just a second because we need it for part D, but we'll be able to double check whether our analysis in part A of the shape corresponds to what we're going to do to the box plot and corresponds to the mean and median theory, okay? So what would happen here is that the median is going to be smaller than the mean. Perfect. So this is just I'm showing you the stem and leaf skewness just because it's an extra way to triple check that your data is okay. That your skewness, reasoning is good. So now let's move on to question B, where we're going to compute the 5 numbers required to construct the box plot. What are those 5 numbers? So I'm going to put them right here in the top. This is either called the 5-number summary, the 5-point summary, or sometimes actually I should say, you'll see the 5 star points for the box plot. So what is the 5-number summary? So the first thing is the smallest value. The second thing is the largest value. so the max and min pretty much. The third element is Q1, your first quartile. The fourth is Q3, your third quartile. And the fifth is the median. So in a midterm, when they ask you for the 5-point summary, these are the 5 things they want. Because from these 5 points, you can deduce pretty much anything else needed to compute and to draw your box plot, okay? So the reason why there's no IQR here, I get asked this sometimes, is because with Q1 and Q3, you can easily deduce the IQR. So there's no need for that. Really, the essential things are max, min, Q1, Q2, Q3, all right? So let's go ahead and compute for those values. So the first one, the min, is quite simple. We have it right here. Our data is ordered. This is super fast. It's 0.2. The second point, once again, fairly simple. Our data is ordered. No way we can make a mistake. 9.7. Then we have our Q1. So our first quartile. So we know that there are 2 things when finding the quartiles that we need. The first is the positioning of the value. And then once we have the positioning, depending on whether it's an even or an odd number, we will either round up or take the average in order to determine the value. Okay, so let's start with step A. Let's find the position. So first quartile, we know that's 25%. So the position is found by doing 0.25 times the sample size, which here will equal 0.25 times 40, which is equal to 10. So that's the position of my value. Now, because it's an even number, in order to determine the value, I'm going to have to take the average of the 10th and 11th position. Okay, so once again, my data is ordered. This makes it very easy to do. Let's go ahead and select those 2 values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 10 right here and 11 right here. So I'm going to take the average of those 2. So it's going to be 1.4 plus 1.5 divided by 2. So this is 1.9, 2.9, I apologize. So this is going to be 1.45. Okay, so that is my first quartile value right here. So let's repeat the process for Q2 and Q3. So I'm just going to write it up here. Q1 is equal to 1.45. And I'm going to repeat the process below here for the other ones, okay? So let's remove this. Let's do the second quartile. So we know the position is 0.5. 50% is the middle. So here also, 0.5 times 40, that's 20. So once again, it's an even number. So it's going to be the average of the 20th and the 21st position. So let's go get those now with the orange right here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that would be the average of 2.9 and 3.1. So let's just erase this right, oops. Sorry about that, right here. All right, so it's going to be the average of 2.9 plus 3.1, so that gives us 6. So my median is 3. So let's go ahead and put it right here. So Q2, which is equal to the median, is equal to 3. And let's go ahead and find the final quartile, which is the third quartile. So we know that that is 75%. So 75 times, whoopsie daisies, 75 times 40 is 30. So once again, because it's an even number, it's going to be the average of the 30th and the 31st position. So let's go ahead and find those. Let's single them out with the red. So we were at 20 over here. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So it's going to be the average of 5.5 and 5.6. So let's go ahead and fill those in right here. So 5.5 plus 5.6. So this gives us a total of 5.55. So I'm going to go ahead and put that up here. So my Q3 is a total of 5.55. All right. So now that we have our 5-point summary, we can go ahead and start drawing our box plot. So we're going to move right on to question C, which is construct the box plot and determine if there are any outliers. Okay, so let's go ahead and do that. Now, before we draw the box plot, there's one more thing that we know that we're going to need anyways, so we might as well just compute it ahead of time and then simply move on to just drawing the box plot. So it's not part of the 5-point summary, but it's easily deduced. The interquartile range, which we know to be the difference between Q3 and Q1, so that's simply 5.55 minus 1.45. So that gives us a total of 4.1. Now there's one more thing that I was just adding to the IQR, in addition to the 5-point summary, that you will need prior to drawing your box plot. It'll just make your life a lot easier, and that is the upper and the lower fence. So let's go ahead and compute those two. So the upper fence, we all know, is the fence that's going to be on the right-hand side. So it's going to be Q3. Okay, it's always the quartile that's closest to that fence. And in this case, since we're moving further towards the right, we're going to add 1.5 times the IQR. So this is going to give us a total of 5.55 plus 1.5 multiplied by 4.1. So this is going to give us a total of 11.7. So that's my upper fence. Now let's do the same thing for the lower fence. So it's going to be the fence on the left-hand side. So the closest quartile is Q1. And since we're moving further towards the left from Q1, we're going to subtract. And we're going to subtract the same thing, which is 1.5 times the IQR. So this is going to give us a total of 1.45 minus 6.15, which is 1.5 times the IQR. And this is going to give us a total of negative 4.7. Okay, so now that we have our two fences, our IQR, our three quartiles that are essential, our max and our min, we can go ahead and draw our box plot. Because we have our upper and lower fence, we can easily determine the unit scale that we want to use for a box plot, right? So over here, we're going to go as low as -5, since our lower fence is at -4.7. And up here, we're going to go as high as possibly 12, 13. So let's go ahead and fill these up. Wonderful. Okay, so we went a little bit overboard. That's fine. Perfect. So the first thing that I suggest you put in is your median, always. So the median is here at 3. So this is my median, or my Q2. Next, I suggest we do Q1 and Q3. So Q3 is approximately over here at 5.55. And Q1 is approximately here at 1.45. Okay, so we have our Q1 and our Q3. Perfect. So now we have our box. Next, I suggest we add our upper and lower fence. So the upper fence is all the way up here at 11.7. And the lower fence is all the way down here at negative 4.7. Okay? Now, I often get asked, until where do the whiskers go? The whiskers go, and this is important, so pay attention. The whiskers go until the last data set before you reach the fence. So what do I mean by that? I know that my upper fence here is at 11.7. What is the last data set before hitting the fence? It's going to be my last data set, which is 9.7, right? So right over here at 9.7, my whiskers are going to go until there. So let's just go ahead and draw these. And this is because my last data set here is at 9.7, okay? So on the left-hand side, we do the same thing. Our whiskers are going to go until the last data set before we hit the fence. So here it's going to be until 0.2, which is, let's say, right around here. So my whiskers are going to go until here, okay, at 0.2. Now, it asks us to find if there are any outliers. How do we determine if there are outliers? So this is where the whiskers come into play. Let's say, hypothetically, okay, it's not part of the problem, but let's pretend that we had another data point here at 13, okay? Outliers are determined by any point within the data set that goes beyond the upper or lower fence. So your whisker is the last data set before hitting the fence, which in this case would be 9.7. And then the next data point, 13, would fall over here, and that would be an outlier, okay? So I repeat that. The whiskers go until the last data point before you hit the fence, and anything beyond that, so any data points beyond the whisker data point is an outlier because it falls outside the fence, right? Same thing for the left-hand side. Okay, so one last time. The whiskers go until the last data point before you hit the fence, and anything beyond that is an outlier. So in this case, are there any outliers? No, there are not. Everything is within the two fences. And finally, they're asking us to comment on the shape of the skewness of the data set. Now, the reason why earlier in the stem and leaf I drew the curve is so you could really see that it was right skewed, because here it's a little bit more difficult. Why? Because you can't, if you trace the shape, most of you will have the just intuition to trace it going this way and then going down like this. I'll draw it here and then I'll erase it real quick just to show you. So most of you will want to go like this, whereas we know that that's wrong because we know it's right hand skewed. So what I suggest you follow more is what I taught you before, which was the mean and the median trick. So you know that if it's right skewed, it's because the median is smaller than the mean, right? Now, how do you tell that by the box plot? It's quite simple. We know that our data is mostly concentrated on the higher end. Okay, notice how within the box plot, it takes up this huge portion, the higher end values. So what does that mean? We know that the mean is a data point that is sensitive to extreme values, meaning that it's going to skew the mean, right? The more we have values that are further at the extremes, whether on the lower or the higher end, it's going to skew the mean. Now here we can see that the higher concentration of values is right here on the higher end. So that means that if my median is at 3, the mean is going to be higher up as it's being pulled by that 7.9, that 9.5, and that 9.7. So it's going to be skewed towards the right. And because of that, we know that the mean is going to be greater than the median, which you can see right here. And so we can tell that it's going to be right skewed. If it was a perfectly distributed bell-shaped curve, we know that the mean equals the median. And what would you see in the box plot? You would see a perfectly even box plot. So the mean and the whiskers would be, and the quartiles, everything would be perfectly distributed. So you would have the same length between the Q1 and the mean and the median, and between the median Q3, and the whiskers would be identical. But this is not the case here, as you can see. And so the graph for a left skewed box plot would be the other way around. You would have a higher concentration of data on the left-hand side, pulling the data towards the left, right? And so that's it for the box plot question. Stay tuned, and we're going to solve some probability problems next.